Ratios and proportions. Made easy. Let's start with ratios. A ratio is a quotient of two quantities. All that means is that ratios are just fractions. However, there are different notations. Here are the three different types of notations. The first one is 1 over 2, which is called fractional notation. The second one is 1 to 2, which is written notation. The third one is 1:2, and that's called colon notation. Let's go over some examples. Example number 1. Write the ratio of 1 to 3. When we see the word 2, that just means division. The first number, 1, will be the numerator, and the second number, 3, will be the denominator. Therefore, the ratio of 1 to 3 can be written as a fraction, 1 over 3. Since we can't simplify, this is our final answer. Example number 2. Write the ratio of 15 to 10. The first number, 15, will be the numerator. The second number, 10, will be the denominator. Therefore, the ratio of 15 to 10 can be written as a fraction, 15 over 10. In this case, we can simplify. 5 goes into both 15 and 10. After factoring out a 5 from both of the numbers, our simplified ratio becomes 3 over 2. This is our final answer. Now, let's go over proportions. A proportion is a statement that two ratios are equal. The easiest way to understand this is by going over examples. Example number 1. Is the proportion true? What it's asking is, are both of these fractions actually equal to each other? The way we determine that is by multiplying the diagonals of the fractions here. So let's look at the first diagonal. We have 2 times 6. We're going to write that down. 2 times 6. And for these ratios to be equal, that means that 2 times 6 must be equal to the other diagonal multiplied by each other. So let's look at the other one. What we have is 4 times 3. Now let's go ahead and simplify. 2 times 6, that's going to give us 12. And that's supposed to be equal to 4 times 3. 4 times 3 is also 12. So since we have 12 equals to 12, that means that this is a true proportion. Example number 2. We want to find out if this proportion is equal. What we do is multiply the diagonal numbers and see if those numbers are equal to each other. Let's look at the first diagonal. We have 2 times 4. And that has to be equal to the other diagonal, which is 5 times 3. Let's go ahead and simplify. The left-hand side, 2 times 4, is going to give us 8. And we want to find out if that is equal to 5 times 3, which is going to be 15. As we can see here, the left-hand side is not equal to the right-hand side. This means that the proportion is false, or that the ratios are not equal to each other. Example number 3. We want to find the unknown number here to make the proportion true. All that means is that we want the left side ratio to be equal to the right side ratio. The way we do this is the same process as all the other ones. All we're going to do is cross multiply. So let's look at the first diagonal. We have a 3 and an n. That means we have to multiply those numbers together. What that's going to give us is 3 times n. And now that has to be equal to the other diagonal numbers multiplied by each other, which is 2 times 30. From here, we can go ahead and simplify. 3 times n is simply 3n, and that's going to be equal to 2 times 30, which is 60. Now what we want is to get this n by itself. Since 3 is being multiplied to the n, what we do is the opposite, which means we have to divide by 3 to both sides. Divide by 3 and divide by 3. These 3's here will cancel, and then what we're going to have left over is n is equal to 60 divided by 3 is 20. So n equals 20 is our final answer.